We are studying sound chapter. We have sound. Sound, it is a chapter. We will explore all about that will be important from this chapter. Okay, from this lecture. Lecture is what sound. Sound. How to produce a sound? How to produce a sound? How is the sound produced? Okay, this will be question. We will have some questions based on this concept. Yes, you are right. These are concepts. Before we do some questions, we need to understand concepts of this. Okay. In front of you is what concept. So here we will understand how to produce a sound, how is the sound produced, what is the meaning of propagation of a sound. Okay. Different wavelength we will be exploring. Refraction, rare fraction, you can compression, vocal cords we will explore. About this ear, I will draw a figure of a ear, and we will see what some main parts. You can see we will divide discussion of a ear into three parts. First will be outer area, second will be medium area, third will be inside area, and third we will talk about. In short, I would like to say we will talk about this ear. Okay, we listen, we hear what sound because of ear. Okay, through this we are able to hear. We are able to hear anything. How sound? How uh, do we hear sound? So it seems magic. You will realize that it is a magic, but no. Behind sound is a what? Sounds, you can say. So let's begin. Here, production of sound. To produce a sound, there is a production from which a sound will come out. For example, this you can take, and other object you can take. This one, and second you will take object, and both you can use both material you can use to produce a sound. To produce a sound. Okay. So here there is a production of a sound from which we produce what we produce. We try to produce a sound. Okay. So here first is what. Do you know what is the meaning of a sound? It is a very easy. Sound, you would say, most of you would say, sound is what? Whatever we hear from our ear is a sound. Whatever you can say, horn of vehicles, music, voice of a fan. You can say voice which comes from factory. What else? What? Yeah, whatever I am speaking is a sound. It is like a sound. Whatever I am speaking, human speaks is a sound. Okay, there are a lot of ways to tell that this is a sound, that is a sound, this is a sound. There are a lot of things from which a sound is coming. And now, if there are a lot of things from which a sound is coming, so people are clear that sound. There will be different types of a sound. There will be different sounds. A woman, when woman speaks, then you will realize woman is speaking like thin voice. Okay, not thick, thin voice. But when man speaks, then voice becomes you can say thick. Okay. So here there are user difference. There are user difference between between man voice and woman voice. Yes, there is a huge difference between man voice and woman voice. One point you also realized what, when children speaks when children speaks, then voice of that children will be what, thin, I think, thin. When they then gradually, slowly, that children uh, that children is getting what, uh, is getting younger, then voice of that children will become what, thick, will become thick. I'm not clear what is a thin and what is a thin. Thick. Thick. Okay. What is a thick? Thin. What is a thick? I don't have a clear meaning of this one. Thick. I am considering thick word as a word, as a this, and I am considering thin word as a like thickness, when we say thickness. Okay. Now vibration produce a sound. Yes, vibration produce sound. One example would you like to see here? This is one object, this is another object. From these two objects, I would like to show vibration. And there is a vibration, you can say that this is a sound which is coming by doing vibration. This is one, you can say our sound is coming. So here, this is vibration, here is happening what, vibration. I used two materials to produce what, vibration, and vibration is coming, then we can say sound is coming. Okay, sound will come. Vibration, which means like that. Okay, like that, wave, like that. Okay, vibration, like that. This is vibration. You can realize in your mobile device, when you do flight mode to your mobile, in your mobile, then there nothing call will come, from your device, because of mobile is in flight mode. Now when you don't want to do flight mode, you don't want that mobile should not be in flight mode. Instead you can do what? Instead you can do one thing, is that reduce, put voice of all, including media, ringtone, all ringtone, alarm. Put all voice of those at 0 level. Then, but there will not be vibration. There will not be still vibration. You will have to do one more thing. Just increase ringtone voice, from which vibration can come. And you put mobile in your pocket. After some time, someone will try to call to you. Then you will then ringtone will not come from your mobile, because of media voice is voice of media is at 0 level. But vibration will come out from your mobile. And you will notice that someone is calling you because of vibration. Vibration which is coming from your device, from your mobile device, is what? Is a ringtone of someone. But this is a option in your device. this is a given. This is a given option in mobile device, so that anybody cannot be disturbed. Anybody cannot be disturbed, but silently that person can know that someone is calling. That's why uh, vibration was applied. Vibration was applied in mobile device. Now, so vibration is just what, like that. Wavelength, you can say wavelength. So one point you have to be clear: vibration will provide vibration will provide sound. If there is a nothing vibration, then of course we can say sound will not come from that device, from anywhere. If there is no vibration, first vibration will happen, then sound will come with that vibration. First vibration will happen, then sound will come with that vibration. Vocal cords vibrate to produce sound in human. Yes. Vocal cord is what? Vocal cord is found in human. Here is a vocal cord, and here you can touch to realize that there is a vibration or not. Just you speak something, okay? Just you. Still, I am realizing that there is happening what vibration. There is a doing vibration. There is happening vibration. So vibration in human will be where? Here, and it is named as a vocal cord. So from vocal cord will happen what? From vocal cord will happen vibration. Okay. So here, whatever we speak, whenever we want to do a speak, so vibrate. So here vibration will happen here. Okay, and when we speak, at the same time vibration will happen. But you can say first slightly few seconds before vibration will happen. Otherwise you can say at the same time vibration will happen when we will be speaking. So second point, you are clear that vibration in human is where found. So here, below the mouth. Okay, here, and it is named as vocal cord. Okay. So to produce a sound from body, sound comes from where? From mouth. But vibration will happen where? Here, and that's it. Now, propagation of a sound. Propagation, otherwise you can say wavelength. Wavelength, which means like this. Okay, like this. This is propagation of a sound. And in other words, you can say this is a wavelength of a sound. In light is also wavelength word. Here wavelength is also in sound. So propagation of a sound looks like this. Okay, like this. From this we need to understand this is wavelength. Okay. Here there is what? You can say here particles are more. But here particles are less compared to this particle. So where particles are more will be considered as a compression because particles are more. So you can say wavelength here is more. Okay, more. And particles are less will be considered as a rare fraction. Okay, rare fraction. We will have some more concepts based on compression and rarefaction. Now, from here, try to understand. This is the exact figure of wavelength of a sound. But in mathematics, in physics, we explain it like that. Okay, like that. This is what wavelength. This is what wavelength. So that is how we will draw figure of a wavelength of a sound. That is how. That is how. So this was compression and this was rarefaction. Rarefaction. From okay, I heard of this is what to propagate there should be what a medium. There should be a medium. If you want what propagation, if you want a wavelength, then there should be a medium. For example, I was telling you with an example, with this example. So this is one and this is one object. Okay, I took this and then I hit on this object. So here is what happening. Wavelength is coming, and little wavelength here will be coming. So this wavelength is also, wavelength is what? Wavelength is a propagation. Propagation is a wavelength. Wavelength is a propagation and propagation is a wavelength. So to produce a propagation of a sound, there should be a medium. I am telling it again and again. Without any medium, there will not be any kind of propagation of a sound. Without any medium, only you will take only one object you will take. Then how will it be possible that one object will produce a propagation, will provide a what wavelength? It will be impossible. Okay, there should be two or more things to see propagation of sound from those objects. Now, apart from this, one example more to understand where propagation can be seen. Where can propagation be seen? Okay, this will be interesting example. Look, there are three kinds of objects. First, liquid. There are three kinds of objects. First, liquid object. Second, solid object. Third, gas object. Okay, gas object. Now, solid, which means there is a what? Solid, which means it will have, solid object will have what? Limit size. Solid object will have limit value or limit volume. For example, this marker. Okay, this marker is a solid. Water is a liquid. Gas is, which is present in a sky, is what? Is gas. Air is a gas. Wind is what? Is an example of a gas. So these were three kinds of objects. Here, from solid objects, propagation can happen. Propagation can come from from solid objects propagation can come. Even from liquid objects propagation can come. Propagation can be produced. From gas materials propagation can be produced. Okay, and these were three objects, and apart from this there are nothing materials apart from this kind of object that we studied: liquid, solid, gas. Okay, I want to write liquid, solid, gas. Clear? From this type of objects can be produced what can be produced propagation. Can be produced propagation of the sound. Otherwise you can say from this type of objects propagation can be produced. Propagation can be produced. Wavelength can be produced. Now what else? For example, water is an example of a liquid material. From water you observe. From water you observe what? Sound. You might have observed. You might have observed, but sound of water. So that sound is coming from water. Water is what object? Water is object, and what kind of object? Liquid material. Liquid object you can say. So liquid, water is a liquid material, and now you are clear that from liquid material sound can come. If sound is coming, it means propagation is happening, wavelength is coming. Okay, vibration is coming. From solid, here we saw this example of this. By taking solid materials we can produce what? Propagation. We can produce vibration. Okay, vibration. Now this compression is what? High. You can say this compression is high, so it means this is what? Wavelength. Otherwise you can say this is a propagation. So it is a high and this is low. This is a high and this is low. It means from this is what? So this is a high, this is high, and this is low, this is low. Okay, that's how you have to understand. Okay, so this area is indicating that it is what? It is at high, like this. This area is indicating that this is low, like this. Okay, like this. So here high, this high we will consider as a compression, and this low we will consider as a rare action. Okay. Now what about a gas? Can from gas material be provided what? Propagation, wavelength, or vibration? Yes. It can happen. It will happen. For example, here, fan is moving. Sound is coming. You can hear. Sound of a fan. Fan is moving. Now vibration is happening. Wavelength is also coming, and sound is also coming from moving fan. You can hear, but sometimes we have to observe that is there a vibration of that object or not. So we will have to observe. Yes, for sound we don't observe. Sound is coming, then we will be, this sound is too much, this sound is too low. For sound we are not able to, for sound we don't care that okay sound is coming, then what else, what, so what. When it comes to how to observe, when it comes to how to observe propagation, how to observe the wavelength, then as we saw, from moving fan, sound is coming, as you can observe, but vibration is also coming, vibration is also happening, and propagation is also coming. What, uh, wavelength is also coming, but wavelength we are not observing. Clearly, we are not observing any kind of a wavelength from moving fan, but we are able to observe what, sound from moving fan. So to observe wavelength from moving fan, we have to observe carefully. Then we will have what, vibration of moving fan, moving fan. Okay. So here compression, you can say this is acceleration. Acceleration is a high, but when it comes to rear traction, you can say acceleration is a low. Sometimes when vehicle is moving on road, okay, vehicle is moving at a constant speed, okay, at a constant speed, but suddenly vehicle driver of vehicle changes speed, okay, changes speed. Driver of vehicle, uh, driver of a vehicle increase a speed of that vehicle immediately, then sound will increase automatically. So here, because sound increased because of as acceleration was increased by by driver of a vehicle. That's how compression comes. Now, when voltage will be low, then it will fan will be moving like that, and sound will be low, vibration will be low, propagation will be what, low. But suddenly voltage increased, then fan will also increase, moving of fan will also increase because of voltage increased, then sound will also increase, okay. So here there will be compression. When this is what, constant, everything is equal, nothing is more, nothing is less, particles are equally, okay, particles are moving equally, it means the sound is coming equally, not sometimes high, not sometimes low, sound is going equally, not low, not high. For example, I am telling you, so this was low, but first was high, so that's it. But when I say I was telling you, I am studying this compression, we are studying reflection. So here, this is sound. This sound is what, at medium. This sound is at medium. So here we will understand this medium line. From this medium line, above this medium line is considered as what, height. Okay. So this will be height. We will understand about it. Medium line I have left. Now let's move ahead. Now movement here, okay. Some questions will be there based on this. Next, human ear. Human ear. This is we have figure of a human ear. This is we have figure of a human ear. Now, from this we will understand something important. This is in a ear canal, pinna, eardrum, cochlear, auditory nervous. Auditory nervous. Pinna is what? Work of pinna is what? From this words, this kinds of words, we will understand what is the work, what are works of all these words. What is the work of a pinna? What is the work of a ear canal? What is the work of a eardrum? All about this we will understand from this. Here, this is a figure of a ear, human ear. Okay. We are breaking down it. Okay. From here to till here, from outside till the inside is what? This is out. We will consider it. We will assume that from here to till here is what? Outer part. You can see from here to till here is outer part. Okay. Outer part of the ear of a human. Okay. Of human. So from here to till here is outer part, and from here, so till here is what? Middle part, and from here to till here is inner ear. So 2 and 2 and 1. So there are 2 in outer, and there are again 2 in middle. There is 1 in 4 inner. For outer area. First first part, this is pena. This is called pena. Okay, pena. Work of a pena is to collect sound, is to collect propagation, is to collect what? Propagation, is to collect vibration. So pena of human ear is to collect sound, is to collect sound. Then sound will go through the ear canal, through the ear canal. Pena will collect the sound, and we will collect sound, and this collection of a sound will go will go through this ear canal. This pipe is what? This pipe, this is not pipe, but this is what? Ear canal, from which sound will go. So work of ear canal is to what? Is to accept all coming sounds from pena. So sound which is coming from pena ear canal will allow to go all sounds that are coming from pena. So yes, work of pena is to collect the sound. Work of ear panel is to allow the coming sound. Allow the coming sound. So you can say sound will travel through ear canal. Okay. From canal you can remember that yes, sound is coming. So through ear canal sound is going. Now through sound is coming through ear canal will 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 arrive where? Here. Will arrive eardrum. And now eardrum will what? Will provide, you can say, will provide vibration. Will do vibration. Okay. Work of eardrum is to provide, is to what? Is to do vibration. Is to do vibration. Is to vibrate. Okay, you can say work of eardrum is to vibrate. Okay. So where will be vibrate? Where will be vibration? Here. So eardrum will vibrate. Eardrum will vibrate. Okay. So this is a small part which will work like this, like this, like this. Okay. So eardrum works like this, like this. So here it is working like this. It means vibration. This is vibration. Okay, vibration. This is vibration. Okay, vibration. And now so work of eardrum is to vibrate. Next, so here we understood what meaning of a pinna, work of a pinna, work of a ear canal, which are in outer area, which are in outer area of a human ear. Now we understood work of a eardrum, which is in middle ear. Now cochlear is what? Cochlear is also here. This is cochlear. Auditory nerves. Auditory nerves. Work of auditory nerves is what? This will provide what? Uh, this will provide signal of a sound to our mind, to our mind. Sound is coming, vibration is happening. So this auditory nervous will tell to our mind, will give signal to our mind. So who gives the signal of sound? So these auditory nerves give what? Signal of coming sound, signal of vibrating sound. Who? This auditory nerve. So work of auditory nerve is to provide information of a vibrating, of a coming sound. Okay, of a coming sound. It will provide all information about sound to our mind, to mind of a human. Okay, so that is how we understood. That is what we were to understood. We were to understand. Now next, sound wave. Sound wave. We understood, we explained that how to represent propagation of a sound in mathematics. Like that we can, like that. Okay, this is wavelength or propagation of a sound. Otherwise, you can say this is wave of a sound. So here we will break down this sound wave. So here, remember, this is middle line. From middle line, we will consider all things. For example, height. For example, wavelength. For example, low pitch, frequency. So we will be able to explore all these things from middle line. So whatever is above from middle line is what? Height. This is height. Okay, this is height. So height of wavelength, wavelength is what? This. This is wave. Don't say that this is wavelength. Okay. So wavelength is what? Just a distance. Just a distance. This is what wavelength. This is wavelength. So first of all, we will have to understand what is this. Okay. What is this? Which is at, this is known as wave crest. This is known as wave crest. Okay. So we will understand that this is a wave crest. So from this wave crest to this wave crest is one wavelength. Is how much? One wavelength. Okay. This is wavelength. This is what? Wavelength. This is one wavelength. This is a two wavelength. This is one. This is one. This is one. But this above is what? Wave crest. But this is low is what? Wave. Wave trough. Wave trough. Okay. This above this surface of the wave is what? Wave trough. This surface of the wave is a wave crest. This a distance between wave crest, between two wave crest is a wavelength. So you would say distance, wavelength is just a distance between two wave crest or wave trough. Wavelength is just what? Distance between two wave crest, between two wave trough. Okay. Wave crest is what? Wave crest is just at a surface of, wave, which is above the middle line. So what about wave trough? What about wave trough? Wave trough is also at a surface of a wave which is below the middle, which is below of the middle line. So this is wave trough and this is wave crest. So wave crest is what? is a surface of a wave. The surface of a wave. This clear. This is height. This is height. This. So it is coming below the line. We will say that this is low. This is low. It is going above below the above to the line. We will say this is high. This is high. Now it is said that wavelength is represented by how lambda. Okay, we will understand it by we will understand it later. Now let's see some formula based on this wave, sound wave. First is what frequency. Frequency is equal to 1 upon time period. Time period. Okay, 1 upon time period. Frequency is just equal to 1 upon time period. Now, new word is coming, which is a frequency. What is the meaning of this now? What is the meaning of this now? But before that, let me write all formula which are based on sound wave. Here, I didn't write a complete formula of time period of first period, but we can find what will be formula for time period, what will be formula of first period from this. Okay, we know formula of first period. Now here, what is the meaning of a new word, which is a frequency? Frequency is just numbers of a something. It is a numbers of a something, something. Otherwise, you can say times of a something. 1 time, 2 times, 3 times, 4 times, like that. So here numbers of a wavelength, numbers of a wavelength, numbers of a wavelength. Okay. For example, one wavelength is one frequency. One wavelength is one frequency. Okay, one wavelength is one frequency. Second wavelength is a second frequency. Okay. So here, how much wavelengths are there? How much wavelengths are given to you? If 52 wavelengths, it means 52. So in 52, in 1 second there will be one wavelength. In 1 second there will be one wavelength. In 2 seconds will be two wavelengths. In 3 seconds will be three wavelengths. So 3 is wavelengths are what? Are frequency. Now time is how much? 3 seconds. So how to find frequency from question? Just write frequency. To find frequency is what? 1 upon time period. 1 upon time period. Time period is what? How much wavelengths are passing from how much times. So that time is time period. Okay, for example, two wavelengths passed by 2 seconds. So 2 seconds is what? Time period. So that is how you will find what? Time period. Now here, this wavelength is what? What is the unit of a wavelength? You would say meter. Okay, because of here we are finding distance. So for a small distance, we take what? Meter. For long distance we take kilometer. But here It is a small distance. That's why we are considering it in middle. Height is amplitude. Height is also considered as amplitude in this language, in language of physics. So height is also amplitude. Amplitude. Now here you can see this wavelength, which means this wavelength is in 1 second. Is in 1 second. So time period, it means wavelength. This one wavelength, how much this wavelength took time to pass from this wavelength. So will be time period. Okay. So here it is as we will just change. You can see we will do what? Cross multiply. This will come here and this will go here. 1 upon frequency. 1 upon frequency. We will do some equations based on this formula. As speed. So as you know, distance upon time. Distance upon time. This was now next. So here SI unit of frequency is what? SI unit of frequency. Frequency is what? Hertz. Okay, hertz. Hz. Hz is the frequency of Hz is SI unit of frequency. Okay. Here from this it is saying from 20 hertz till the 20,000 hertz human can listen any sound, but sound will be from 20 hertz till the 20,000 hertz. If a hertz is above the 20,000, then human cannot hear. Okay, cannot be able to hear anything. And from below the 20 hertz, again human cannot hear what? Any sound. Okay, so this part is for women. So from 20 hertz, from 20 hertz, above the 20 hertz, human can listen, human can hear anything. Below the 20,000, below the 20,000 hertz, human can hear anything. But when it comes to what 20, hertz is above the 20,000, then we can say human will not be able to listen. Okay, human will be like that. Okay, like that. I can't not hear because of frequency of that sound is above the 20,000 hertz. Okay, now this part 20 a hertz hz hertz which is below the 20 hertz is a category of infrasound and go here infrasound. For example, elephant animal, elephant animal. Okay, animal. Insects. Okay, animal like elephant will listen any sound, will hear any sound if a sound frequency of a sound is what below the 20 hertz, then elephant can hear. But heard frequency of that sound, frequency of any sound is above the 20,000 hertz, then insect 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 can hear the sound, can hear the sound. Clear? So this part is what ultrasound. It means, and you can say 20 hertz. From 20 hertz to the 20,000 hertz is what medium, is medium you can say. Below the 20,000, below the 20 hertz is what infrasound. Above the 20,000 hertz is ultrasound. Of course, it will be ultrasound. Okay, ultrasound. What? Ultrasound. Clear? Ultrasound. So audible sound for human is what? From 20 hertz to the 20,000 hertz. SI unit of a frequency is hertz. Okay, we represent frequency as a hertz, as you can see here. From this we understood that ultrasound is for those insects, for those insects. Infrasound is for animal like elephant. They are able to hear. They are able to hear anything if a frequency of any sound is below the 20 hertz. We are able to hear anything if frequency of any sound is between 20 hertz to what 20,000 hertz. Then any person can hear. And from 20,000 hertz, those type of insects can hear. Okay, this is what we understood from this. Now next. Noise. How does noise come? How does noise come? Noise pollution. Okay, noise is just pollution. We don't want any type of pollution, any type of noise pollution. Okay, noise is also sound. But we want what? We want interesting sound that we can hear. Okay, hear in comfortable zone. For example, horn of vehicles we don't want to listen. We don't want to hear. Any song, any this type of music is what is running on a speaker, which is not which is not right, which is not a correct music. So those kinds of sounds are what? Noise pollution. Any sound, if you are not able to hear, if you are not able to hear any type of sound, whether it is a sound of a vehicle, whether it is a sound of music, whether it is a sound of a person, if you are not able to hear, you cannot hear, then those sounds are not what? Those sounds are noise pollution. Okay, for example, sound is high on a speaker is a noise for people. A sound of vehicles, sound of vehicle, sound of a lot of vehicles is a what? Noise, which is a pollution. High high sound can damage to our ear. High sound, sometimes we can have headache here because of noise pollution. So this is a what? Disease, you can say. This is a disease that no one wants. No one wants. So any sound which no one wants will be considered as noise. Okay, will be considered as noise. And here, how to reduce noise pollution? How to reduce? Just we will have to plant. We will have to plant a tree. We will have to what? Accept more trees to plant in area where is empty. Hmm. What else? That's it. Now let's take some question based on this. We have this first question based on concept. Identify the part. We have to identify the part from which will vibrate, from which that part will vibrate to produce sound. So in this given, we will have to identify which one part is what vibration will provide vibration. So Dolak is an instrument. We have three kinds of instrument. First is a dolak, second is a flute, third is a sitar. All these three have a what? Vibration part. Have a vibration part. Part from which sound comes. From which sound come. From which for example, dolak has a what? A part from which uh, sound will be sound will be produced sound will be produced uh, vibrate will be produced from part of a dolak. So dolak has a membranes, as you know. Dolak has what? Membrane. Okay. String. We have three three kinds of instrument. First is dolak. Second is what? Sitar. Sitar has what? Sitar has a string. Yes. And flute has a air column string. And third instrument, which is the last, is what? Flute. Flute is what? Flute has a air column. Flute has a air column. Air column. Okay. So here, this is a part of a dolak from which vibration will come. This string is a part of a sitar instrument from which vibration will from which there will vibrate. There will be vibration. This air column is not a part. Air column is what? Air column, you can say air column is a empty part from which air comes, air goes. Air comes, air goes. It is a part which is empty part is found in flute instrument. Now, which one is the correct option for this question? So dolak should have what? Membrane. So this, okay. Sitar should have what? String. So this is not. Dolak has this is also not. Dolak has not. Dolak has membranes. Yes, it is correct. Sitar has a string. Yeah. Flute has what? Air column. So this D is the correct option for this question. For this question. Okay. So dolak will have what? Membrane. Sitar will have string. Flute will have air column. Flute like that, and inside part is empty. And this person produces sound. Person produces sound from flute instrument. I don't know how. So here, inside part is what? Is empty part from which vibration comes, from which sound comes, from which wavelength comes. And dolak like that. Okay, like that. Dolak like that. So like dolak like that. So that's how vibration comes. That's how. Okay. Sitar has a string like that. String. Okay, like that string. Sitar has a string like that. And person to personate with the figure like that on string on string of a sitar instrument, then sound is produced. then vibration happens. This was one question based on this. Next question, which is a statement. Yes, we have this two statements. We have this statement. If you are thinking that this statement one is incorrect, then okay, you are correct, but you have to tell reason. Second is correct, then okay, again you are correct, but you have to tell reason. There should be logic behind answer. Okay, behind answer. So answer should be what? Let's read. Let's read first. First statement. The larynx is an essential organ. The larynx is an essential organ in the human body to produce a sound. Larynx. I don't know. Larynx is what? Larynx should be vocal cord. I think it would be pipe. Okay, this pipe. If yes, then we can say okay. Yes, it is an essential organ part of the human body, so that human can produce what? So that human can produce a sound. If larynx is a what? Pipe like that here, there, okay, like that. Then we can say yes. Statement one is the correct. It is statement one is saying that larynx is a organ which is essential in the human body from which sound is produced. This is one statement. We have to tell it is a correct or not. Yes, correct. Because if larynx is this part which looks like a pipe, then it is a correct. Statement 2. The vocal cord. Vocal cord is found here. The vocal cord is found here from which vibration happens, from which sound comes like that sound. We speak because of anything because of a vocal cord. Because of a vocal cord, first vibration will happen. Then at the same time we are able to speak. We are able to speak. Okay. So the vocal cords open during breathing to allow air into lungs. Yes, we can breathe. I am speaking. Can we not? Cannot be cannot we take breath during speaking anything? Cannot we take breath during speaking? During speaking, cannot we take breath? Yes, of course we take. Of course, we can take breath, and here will go into our lungs, into our lungs. Yes, it can happen. It happens. Okay, it happens. So vocal cord opens during breathing. During breathing, I am like that. I am speaking. The vocal cords are during breathing to allow. So of course, this statement 2 is also correct. We are able to speak, but I am not saying confidently. We are able to. Yes, yes, yes. It is correct. It is saying is correct. The vocal cords open during breathing to allow air into opens during breathing. When we speak, then what? Vocal cord will open. When we speak, when we speak, then vocal cord will open, and and it will take what? Air as a breathing, as a breathing, as a breath. Yes, the vocal cord opens during breathing to allow air into lungs. If we will not take air, if we will if we will not take air, if we will not take a breath, then how can we live? How can we live? No, it is impossible. So we will have to take what? Breath. So during what? If a vocal cord is open, then yes, we can we can take a breath when vocal cord is open, and air will go, or air will go. So it allows, this vocal cord allows to pass air from outer till the lungs, till the lungs, and air works properly. Okay, properly. It should happen. Okay. So both statements are correct. Are correct. Okay, brother? Are correct. Now, second question. So this is the second question. It is saying sound will not be able to travel in which part, in which material. This is one material. This is also liquid material. This is a gas material. This is nothing. Vacuum, which means nothing. You can say this is nothing. Nothing part in which there is an empty area. So sound, where can sound not travel? Where can sound not travel? Sound can, so to provide a sound, there should be what? A wood. From wood material, sound can be produced. Sound can be produced. So of course, water. This is what? Material. This is also material. This is also material. Vacuum is not material. It is an empty area. Vacuum is empty area. So sound cannot travel in empty area. To sound travel, there should be a medium. To sound travel, to travel sound, there should be any medium. So vacuum is a thing, is a not thing. It is a option. It is a answer for this question. Sound cannot travel in vacuum area, in empty area. Okay, sound cannot travel in empty area. Now next question, which is very interesting. This is an expression. This is an expression. It is a saying. It is a saying. Which of the following is are functions of the air? Function of air, from which we are able to hear anything. Okay. Air functions. That's why a uh, mind are able to take what mind takes information from anatory nervous. Okay, anatory nervous. So anatory nervous is also a function part of the ear. So here collects the sound. Collects the sound. Function of the ear. Collects the sound. Yes. Function of the ear amplifies the sound. What is? Sound is low. Sound is high. Who tells? So function of the ear. Converts the sound vibration into electrical impulses. Yes. And then nervous provides this signal to our body, our mind. All of the above. Yes, this is also, this is also, this is also. So pena is a function. Pena is a part of the air which collects the sound, amplifies the sound. So we will amplify. Here anatory nervous part of the ear provides what information provides a signal to our body, converts the sound vibration into electric impulses. Yes, uh, it happens, it is converted by function of the ear. So all these are works of functions of the of ear of woman. So D will be answer. D will be answer.